Section 3.2 deals with values of trig ratios, and we're just going to start off with the more common trig angles, which are 30, 45, and 60. And we're going to start off with 30 and 60 because those are complementary angles. They add up to 90 degrees and they fit within the same triangle. So suppose you have a triangle that is an equilateral triangle. Now, if you recall, an equilateral triangle is a triangle in which all three sides are the same length, and hence all three angles are the same angle. Since all triangles have angles that add up to 180 degrees, that means that if we have three angles that are the same, that each one of these angles is 60 degrees. And since this one up here at Q is split in half, each one of these would be 30 degrees. Now suppose we just let each one of these sides be 1 unit. So those two would be 1, and then down here this is split in half again, so each of these would be 1/2 of a unit. So if we want to look at the trig ratios here, the first thing we need to do is we need to find our height here. We have our hypotenuse, we have our base, and I'm going to come down here and draw this, look at this triangle. Again, this is 60, this is our 30, and this would be our 1/2. We need to find that height from Q to R. And if we do that, we can use the Pythagorean theorem. We know that we have 1/2 squared plus what I'm going to call QR squared, and this is going to equal 1 squared. Well, 1/2 squared is 1/4, plus we still have our QR squared, and 1 squared is just 1. We subtract that 1/4 over, and we have QR squared is going to be 3/4, and then we would take the square root of both sides. We only care about the positive in this case because we're talking about a length. So our distance QR here is the square root of 3/4. Now we don't like to leave fractions in a square root. So first thing we can do is split this up to be the square root of 3 over the square root of 4. And we can simplify the square root of 4. So we're left with the square root of 3 over 2. And so this would be the simplified distance here, square root of 3 over 2. And so these are all of our lengths. We can now find our trig ratios. And I'm only going to worry about sine, cosine, and tangent for these. So we found this height here to be the square root of 3 over 2. If we want to find, for instance, the sine of 60 degrees, well, the sine of 60 degrees is going to be the opposite, which was the square root of 3 over 2, divided by the hypotenuse, which was 1. So this just simplifies to be the square root of 3 over 2. If we want to find the cosine of 60 degrees, we will have the adjacent side, which is 1/2, divided by 1. Again, this simplifies to just simply be 1/2. Finally, the tangent of 60 degrees is going to be the opposite, which was the square root of 3 over 2, divided by the adjacent, which is 1/2. If we look at our division of fractions, this is the square root of 3 over 2 times the reciprocal, 2 over 1. 2 divided by 2 is just 1. And we are left with the square root of 3. So those are our 3 trig ratios for 60 degrees. What about for 30 degrees? If we look at our 30-degree angle up here, the sine of 30 degrees, well, opposite to that is 1/2. Hypotenuse is still 1. This reduces to be 1/2. cosine of 30 degrees is going to be the adjacent side, which is the root 3 over 2 divided by the hypotenuse, which is 1. And this comes out to be the square root of 3 over 2. And the tangent of 30 degrees is going to be the opposite, which is 1/2, divided by the adjacent, which is the square root of 3 over 2. And again, if we want to look at dividing fractions, we have 1/2 times 2 over the square root of 3 if we flip that fraction over. Again, 2 divided by 2 is 1. And this time we are left with 1 over the square root of 3, which we don't like to have radicals in the denominator, so we're going to multiply by root 3 over root 3, and we are left with root 3 up top, and root 3 times root 3 is just 3 in the denominator. So this would be the simplified version of the tangent of 30 degrees. So if you might have noticed, sine of 30 degrees is 1/2, cosine of 60 degrees is 1/2. Similarly, sine of 60 degrees is root 3 over 2, cosine of 30 degrees is root 3 over 2, and this has to do with the fact that these are complementary angles. Again, complementary angles are two angles whose sum is 90 degrees. In other words, they form a right angle when put together. And so this is what the two angles in a right triangle that are not the right angle always end up being, because the right angle is 90, an entire triangle is 180, so we end up with the other two angles adding up to be 90. Now we can learn that cofunctions are functions on complementary angles. So as we just showed, sine of, for instance, 60 degrees is equal to cosine of 30 degrees, because this is the complementary angle. This is saying that we found the sine of the complement of 30 degrees. That would be how we would write it. Complement of 30 degrees is 60, and so we have the same thing. Likewise, the sine of 30 degrees is going to be the cosine of 60 degrees. So no matter what two complementary angles you find, the sine of one is going to be equal to the cosine of the other angle. One last example here, and this is going to deal with a 45-degree angle. Again, 45 and 45 and 90. So we're going to suppose that this is 45 degrees, this is 45 degrees, and instead of the hypotenuse being 1 in this case, we're going to assume that both of these sides are 1 unit. So in this case, we need to find the hypotenuse. We have 1 squared plus 1 squared is going to be c squared. So we end up with 2 is c squared, or c is the square root of 2. And that is your hypotenuse there. So if we want to find the sine of 45 degrees, we can use either one of these angles, because they're both 45. And we end up with the opposite being 1 over the square root of 2. Again, we don't like radicals in the denominator, so we are going to multiply by the square root of 2 over the square root of 2. We're going to multiply by 1, because anything divided by itself is 1. And we're going to be left with a square root of 2 over square root of 2 times square root of 2 is simply 2. Now take a second here and find what cosine of 45 degrees and tangent of 45 degrees are going to be. So you should have found that cosine of 45 degrees is the same as 45 degrees. Again, these are cofunctions. And you end up with a root 2 over 2. Tangent of 45 degrees is opposite of over adjacent, both of which are 1, so we end up with a fraction of 1. Now, this concludes the video on the introduction to some of the basic angles.